everyone, this is Sherry and today we'll together solve the LeetCode Daily Challenge for January 2nd, convert an array into a 2D array with conditions. This is a medium level question which practices the use of hash map. So without further ado, let's get started. Let's start by reading the problem statement on the left side of the screen. You're given an integer array nums and you need to create a two-dimensional array from nums satisfying the following conditions. First, the 2D array should contain only elements from the array nums. Second, each row in the 2D array contains distinct integers. Third, the number of rows in the 2D array should be minimal. Finally, return the resulting array. And notice that the order of the 2D array does not matter because we can return any qualified array as long as the 2D array has the minimum length of 1D arrays. Sounds quite complicated, right? Let's rephrase the question into human readable words. This question can be reduced to we need to divide elements from the input array into groups such that each group should not have any duplicates. And also, we should minimize the number of the groups. Return the groups in the form of 2D arrays. That's all. Here, we will use the food analogy as an example. Imagine you're given a pile of M&M chocolates and you need to sort them into groups that satisfy the rules above. The given M&M chocolates are just a random mass and it still sounds quite complex and it is really not a great starting point to solve the question. However, we can transform the jumbled input into a well-organized hash map, enabling us to swiftly access a count of M&M chocolates by their varied colors. As you can see, after we organize our input using hash map, our input has become easier to work with. In fact, there are two ways of using hash maps to solve this question, so let's work through them one by one. We will walk through the logic together before we get to the detailed solution. In solution number 1, our hash map focuses on what elements are left in the input array, and then we can derive what elements to add in each 1D array. This step goes like the following. We use hash map to track what elements are left in the nums input array. Then, after we build our hash map, we iterate through our hash map, and in each iteration, we take one number of each entry to add to our new 1D array to construct our 2D answer array. We will see this in detail in action just a bit later. In solution number 2, we focus on what we have in our answer array and also where to add our next element. In this solution, we use hash map to track what elements we have already added into our 2D answer array. Then, we iterate through the input array. In each iteration, we place one element from input array into our 2D answer array. It is okay if you feel confused, but trust me, this will make more sense when we get to the real test cases. We are going to apply solution 1 to solve this test case. Again, the logic of each solution is attached to the right bottom of the screen, so you can look it up and check it out anytime you feel confused or you feel like you need to go through the logic again. In solution 1, we use hash map to track what are left in the input array. We first turn the input array into a hash map counting frequency of each number, and this gives us a nice starting point to construct our 2D answer array. We will now do the iteration over our hash map. In each iteration, we take one number from each entry into our 1D array. Here, we take a 1 and a 2, a 3, a 4 into our 1D array. Because we need to minimize our number of 1D array, we need to put as many elements into array as possible. We then decrement the corresponding number count by 1 because we have already placed them in our answer array. Because we still have some elements left in our hash map, which means that we still need to do the allocation, so we need to continue our iteration. In the second iteration, we have 2 1s and 1 3 left in our hash map. So as usual, we will just take 1 out and a 3 out into our 1D array, so that as you can see, the second 1D array is formed by a 1 and a 3. Now we can see there is still a 1 left in our hash map, so we can just add a 1 to our third 1D array, and thus these 3 1D array formed our 2D array as the answer. This example demonstrates the benefit of using a hash map. We track our grouping process easily, how many numbers are left in our input array. Also, we avoid duplicates without any duplication check. Great! We have now successfully solved a test case with our solution number 1. Here are the detailed implementation steps. First, we count the frequency of numbers in a hash map. Second, we initialize an empty 2D array as the result. We then distribute elements across rows using while loop. And finally, we return the 2D array as the answer. The time complexity for solution 1 will be O of n, which is linear time, because we iterate each input element inside our input array to construct our hash map. And then for the while loop, we still use linear time. We also use O of n for space complexity, because as we are constructing our counter or the count hash map, we are using up the space complexity for O of n, where n is the number of unique elements in nums. And in the worst case, if every element in our input array is unique, then the worst case space complexity for our hash map will be O of n. Also, because our answer 2D array has the same size as our input array, so building the answer 2D array uses the linear space. And finally, this is our code for our solution 1. First, we initialize the count to count the frequency of numbers. Second, we initialize the answer array to return. And third, while there are numbers left in our nums input array, we build a new array named newArray and append our new array to answer array. We iterate through every key value pair inside the count, and if we find a frequency larger than 0, which means that we can allocate this number into our new array. After a number from input array is allocated, we will decrement its frequency recorded in our count hash map. This while loop will break if it turns out that our constructed new array is empty. This indicates that even though we have illustrated every key frequency pair in our count hash map, we don't find a valid or unallocated input element in our hash map, so that we should now end our while loop. Finally, we return the nth array as the answer. Now we will walk through solution number 2 and see how we can use our hash map differently to solve this question. Here, we use the hash map to track what elements we have already added to our 2D answer array, or in other words, what's now currently inside our answer array. So at the beginning, we have nothing in our answer array because our answer array is empty. So we have a frequency for 1 which is 0, and we have a 0 frequency for 2, a 0 frequency for 3, and 4. The key frequency pair inside our hash map is actually really interesting because the frequency can also denote the index of the 1D array to add. For example, if we will have a 1, then the next one should be added to the 1D array at index 0 of our 2D answer array. We will see this in action really soon. Here, we will walk through the same example we used for our solution 1. You can see there is a brown arrow pointing to the 1 at index 0 inside our nums array. In this iteration, we need to process this 1 at our index 0. So we look up into our hash map and find the index of 1D array to add for this 1. The value in our hash map for key 1 is 0, which means that we need to add the next one to 1D array at index 0 in our 2D answer array. We don't have any 1D array inside our answer array yet, so we will now init our first 1D array and make it the 1D array at index 0. Finally, we will add our 1 into it. After adding our 1 at index 0, don't forget to update the number of 1 stored in our answer array. We will now process the 3 at index 1. And since we don't have any 3 in our answer array, the index for 1D array to add inside our hash map is still 0. This means that we should add the next 3 to 1D array at index 0. Therefore, the 1D array at index 0 of our answer array is now consists of 1 and 3. We will now do the same for the rest of numbers inside our input array. For the 4 here, because the index of 1D array to add is 0 as indicated in our hash map, we will add our 4 to the 1D array at index 0 so that our index 0 1D array is now consists of 1, 3, and 4. Now we encounter another one in our input nums array, and this time we already have a 1 stored in our answer array because if we look up in our hash map, the value for key 1 is 1, which means that we should add the next one to the 1D array at index 1. However, we don't have a 1D array at index 1 yet, so we will now initialize this 1D array and then add our 1 into it. We will now quickly go through the rest of the nums inside our input array. So for the 2, we look up in our hash map and find the value for key 2 is 0, which means that we need to add this next 2 into our 1D array at index 0, and therefore now the 1D array at index 0 is now 1, 3, 4, and 2. To add this next 3, we look up in our hash map to find the index of array that this 3 should be inserted into, and we find 1 as the value so that we know we should add the next 3 into the 1D array at index 1. So now our 1D array at index 1 is now 1, 3. We will now add our last number inside our input nums array, which is again a 1. And now you should know the drill. We look up in our hash map and find the corresponding value for the key 1. And we now know that we should add the next one to the 1D array at index 2. And since we don't have an array at index 2 yet, we will initialize the array and add our 1 into it. Finally, after we finish the iteration through our input nums array, we have already allocated all the elements inside our input array into our answer 2D array, so that now we can return our answer array as the answer. Now it's time to format our logic into actual implementation steps. We first do the initialization. We initialize hash map name count to track numbers we have stored into our 2D answer array, and also we initialize empty 2D array name ans. And then we iterate over the array nums, and for each integer current noun, we will call it current noun. We store current noun to 1D array at index count current noun. If such 1D array doesn't exist, then we initialize the array. And also, don't forget to increment the frequency of current noun inside count hash map. Finally, we will return ans as the answer. The time complexity and space complexity for solution 2 is actually the same as solution 1. We use linear time complexity because we iterate over the array nums once to insert them into our answer 2D array. And also, in each iteration, we access and update hash map, which takes constant time to do. And also, for the space complexity, which also use linear O of n time because we need to store the input array elements into our counter count hash map, and the space complexity for the counter is O of n, where again m is the number of the unique element in nums, and at the worst case, this can be linear time, which is O of n, at the worst case, if every element in our input array is unique. Let's get to the actual code for solution 2. First, we do the initialization. We init the count as the hash map to store the frequency of numbers. Also, we init the answer array to return named ans array. And also, we iterate through the input array. In each iteration, we store current num into our target 1D array. And how do we know which array is our target 1D array? We do the lookup in our count hash map. The index of our target 1D array would be the value for the key current num. Also, if the target 1D array does not exist, we need to initialize an empty array as the target array and then append our current num into it. Also, don't forget to update the frequency inside our hash map. Finally, we return the answer array as the answer. That's all for today's daily challenge. In this challenge, we implemented 2 solutions using HashMap. Just remember, HashMap is always your friend when you find yourself looking up for values frequently. I'm Sherry, and I hope you enjoyed today's video. I will see you in the next challenge.